All right, welcome. Here we go. We are now going to talk about the product and quotient rules primarily, and we're going to use those to kind of uncover some other derivative rules and shortcuts that you need to know. Okay, so product rule. So as functions become more complicated, when you have the product of two functions, in order to take the derivative, you would take the first function, which is f of x. Oh, pen just shut off. Which is f of x. Multiply that with g prime of x plus, then you would do f prime of x times g of x. Okay, so in other words, you take the derivative, or scratch that, you take the first function times derivative of the second plus derivative of the first times the second function. Okay? That's the product rule. So you can use that now to take derivatives of problems, for example, like this one here, where you have x squared plus 8x times 4x cubed minus x. Now you could multiply this out and FOIL and do all that stuff, and then use the power rule to get your final answer, but you could also just follow this roadmap. And so what you would do is you treat this, whoop, so this would be f, and this one here would be g. All right, and so if you're going to go ahead and find the derivative, then all you would do is take the first function, which is x squared plus 8x, and now multiply that with the second function's derivative. So for that one, I'm going to do the product rule. You're going to get 12x squared, or I'm sorry, I'm going to do the power rule to get 12x squared. Same thing with the minus x, that becomes minus 1. Plus, now you take the derivative of the first one, so use the power rule there, you get 2x plus 8, and now multiply that with the second one, so that's going to be 4x cubed minus x. Okay, and if all you need is a derivative for f, here is a derivative for f. Okay, if you need to multiply it out and simplify for something else, then you can go ahead and do that. But if you just need to report, what's the derivative of f, this is good enough. Okay. So again, maybe I should mention this more, but as I'm going through these notes in the video, okay, anytime I'm going through an example, if you kind of know what to do, or if you have an idea, it's not a bad idea to pause the video and see if you can get the answer first before I go over it. Okay, I'm going to go through these pretty quickly, so it is important to kind of pause and process a little bit, and maybe even try to get the answers on your own first before seeing them and hearing them. All right, so moving on, let's go ahead and try to find h prime of x. Notice here we have, again, there's f, and then we can say g is the sine of x. And so I would go first function times derivative of the second one, so that's cosine x, plus, and now you take the derivative of the yellow, which is going to be 2x squared. Multiply that with the second one, which is sine of x, and we're done. So there is the derivative of h. Okay, so for all these, we're just finding the derivatives. All right, g prime of x. Same idea, so I'm going to split it as 2x and e to the x. Okay, not a good idea to do 2 and then x e to the x, because then you still have this thing here, which you need to split up anyway with the product rule. Okay, anytime you can use a polynomial like 2x, or if it were like x squared plus 5, that's a polynomial, you treat that as one of them, and then the other function, whether it's a trig function or an exponential, that would be the second function for the product rule. All right, so anyway, first function, 2x. Second function, derivative. For e to the x, the derivative is e to the x. Now we take the derivative of the first one, so that's going to be 2. And again, second one is just e to the x, so there you go. All right, let's go on to example 4. Now let's see if we can apply this new knowledge to find another tangent line equation. We were looking for the tangent line at x equals pi for f of x equals 4x cosine x. Okay, so obviously for a line, we need a point and a slope. Now the point, I already know, is going to have an x-coordinate of pi. You can plug that in to x to figure out what the y is going to be. So that's going to be 4 times pi times the cosine of pi. And so that's 4 pi. Cosine of pi is negative 1. And so I get negative 4 pi. So there's my point. Now we just need the slope. Now we have a lot more tools that we can use to find the slope, right? To find the slope, we need to find the derivative. So let's find the derivative of f of x. And again, I'm going to use the power rule. So I'm going to look at 4x as function number 1 and cosine of x as function number 2. So we're going to do 4x times the cosine of x, take the derivative of that. That's going to be negative sine x, plus derivative of the first one is going to be 4, and then we just have cosine of x. And now we want to plug in our x value into the derivative so that we actually figure out the numerical value of the slope. Remember this formula here, f prime of x, that tells us how to find the slope at any x value. So once you know the x value, you plug it in to figure out the numerical value of the slope at that location. So we're going to have 4 times pi times negative sine of pi plus 4 times the cosine of pi. And so if I simplify that, the sine of pi right here, that's going to be 0. So this entire thing drops out. And now I just have the cosine of pi times 4. So that's 4 times negative 1, which is negative 4. And so there's my slope. My slope is negative 4. There's my point. And so now your final answer, you can just use point slope form. It'd be y plus 4 pi equals negative 4, which is the slope, times x minus the x-coordinate. And there is your tangent line equation. Okay? All right, cruising along. So that's a little bit about the product rule. Now we're going to go talk about the quotient rule. Okay, so the quotient rule looks like this. It's a little bit more involved, but it is the lower function, g of x, times the derivative of the higher function minus the higher function, which is f of x, times the derivative of the lower function all over the lower function squared. Okay? It's kind of an awkward formula at first, and it takes a little bit of practice to get used to it. But if you think about the formula like this, low d high minus high d low all over low squared. That might help you remember it. It just kind of flows better. Low d high minus high d low over low squared. Low d high minus high d low over low squared. And what I mean by low, low refers to g of x, right? and high, that just refers to the function at the top, which is f of x. Okay? And so that's where we get this. G of x is the lower one. The derivative of the higher one would be f prime of x. Okay? And so on and so forth. So there is the product rule, or I'm sorry, the quotient rule. So now let's use that a couple of times, see how it's going to pan out. And so if I wanted to find, f prime of x for this quotient, okay, I'm just going to follow my roadmap. I do low, d high. So the derivative of the numerator is 4x minus high, so that's 2x squared, d low. So the derivative of the lower function, that'll be 2x all over low squared. So take the denominator and square it. And there you go. There's a derivative rule for this quotient. Again, you guys should be comfortable multiplying it out and simplifying and doing all that if necessary, but if all you need is the derivative rule or the derivative formula, this is good enough. All right, let's go on to example 6, g prime of x. Same kind of thing. Another quotient, so we do low, d high. Okay, so here's maybe where we have a little curveball. Square root of x, that's really the same thing as x to the 1/2. Okay? It helps to sometimes rewrite radicals as exponents, because now you can do the power rule, right? This 1/2 comes out in front. You still got the x, and now you decrease by 1. So 1/2 minus 1 is going to be a negative 1/2 exponent. Okay? Minus, and now we have x to the 1/2, because that's high. And then d low, so the derivative of the denominator is cosine of x all over low squared, so that'll be sine squared of x. And there you go. Okay, once you do this a few times, low d high minus high d low over low squared, you start to remember it. Okay. And actually, yeah, let's look at example 6 or 7 rather. The reason this is there is actually to remind you that not every single time do you have to do the quotient rule. This you can actually rewrite as 6x to the minus 3, and now you can do power rule. Right? So that means h prime of x, if you do the power rule, you do negative 3 times 6, that's negative 18, x, decrease the exponent by 1, so that's x to the minus 4, and there you go. A lot faster if you recognize for a simpler problem like this that you can just rewrite it and then do the power rule. Now if you do the quotient rule, it's still going to work, but it's just a little bit more work than you need. All right, and now example 8. So we got some trig functions here, so let's go for it. F prime of x. How do I find the derivative of this quotient? So that's going to be low, d high, so sine of x, take the derivative, that's cosine. Minus high, so that's sine of x. D low, so that is going to be negative sine of x over low squared, so that's cosine squared of x. Now, this looks like it turns into something, so let's keep going with this. Cosine times cosine is cosine squared. Negative sine times negative sine is positive sine squared. Oh, that's convenient. I hope you remember, cosine squared plus sine squared is 1. 1 over cosine squared is just secant squared. And so this derivative turns into secant squared. Now, let's go back. We just uncovered a new rule. Remember, sine over cosine, That's really just tangent. So what we just verified or just proved using the quotient rule is that the derivative of tangent, so if I were to take the derivative, so this is kind of a side note here, the derivative of tangent of x, that will be secant squared of x. Pretty cool. Okay? So actually, that's where this first formula comes from. Okay? These other ones can also be found similarly by doing quotient rule. Okay? Now, we're not going to do all four of them, but just know that you can derive these just as easy. But you do need to start learning these new ones. The derivative of tangent is secant squared. Derivative of secant is secant tangent. The derivative of cotangent is minus cosecant squared. And the derivative of cosecant is minus cosecant times cotangent. Okay? Those are, we're throwing a lot of formulas at you, but you will use them quite a bit, and so you will remember them. Okay? All right, so now let's put some of these new rules together with this example here. So if I wanted to find g prime of x, okay, first function is going to be secant, second one is going to be tangent. And so again, I'm going to use product rule. We do not have a rule for secant tangent. We have a rule for secant, we have a rule for tangent. Okay, so we're going to do the product rule. So now we do first function, so that's secant of x, times the derivative of the second one. So we're looking at tangent, and I know the derivative of tangent is secant squared, plus, now we do derivative of the first one, so we're looking at secant. The derivative of secant is right up here, that's secant tangent, so we do secant of x times the tangent of x, and then take the second one, which is tangent of x. And so there you go. Doesn't look like that really turns into anything convenient, so we can leave it that way. I guess if you really wanted to, you can do secant cubed plus secant x tangent squared of x. That's the same thing, but again, there's either one of those is fine. All right, we're going to end with this final example here, and I'm just going to do the first one, and it's not too bad. We're just applying these new rules, but using a table. Okay, so that's not too bad. So let's look at part one. So if we want to find h prime of 4, I'll write that down over here. So this is part 1. H prime of 4. Notice, I guess it's h1 prime of 4. Notice that we have f of x times g of x as the definition of h1. So we're going to have to do product rule. So if I'm following the rules from above, right, all the way at the beginning, we're just using the product rule and applying it in this context. Instead of f of x and g prime of x, since I actually know the x value, it's easy to just go ahead and write it out that way with the x value plugged in. So it'll be first function times the derivative of the second plus first function derivative, so f prime of 4, times second function, so g prime, or I'm sorry, g of 4. And now we know what these are from the table. So if I look at f of 4 is right here, it's just 3. So there'll be 3 times, and now we look at g prime of 4, that'll be 1, plus f prime of 4, f prime is right here, that'll be negative 1, times g of 4, that's just 4. And so if we clean that up, that's 3 minus 4, which is negative 1. Okay, for part 2, it's the same kind of thing. So let me do that. Part 2, if I want to find h2 prime of 3. Since this is a quotient now, right? This is a quotient. We're going to do the quotient rule. So that'll be low. So that's g of 3, d high, so f prime of 3, minus high, d low, so f of 3, and then g prime of 3, all over low squared. So g of 3 squared. Plug in the values. G of 3 is 3. Let me actually change colors here, make it a little darker. So g of 3 is going to be 3, right there. F prime of 3 is going to be 0, so 3 times 0, minus f of 3, that's going to be 4. And then g prime of 3, that's going to be 1, all over g of 3. G of 3, again, that was 3, so that'll be 3 squared. So if we simplify that, it'll be 0 minus 4, that's negative 4 over 9. Negative 4/9 would be the answer for that one. Okay, problem 2 is essentially the same thing. You can try that for practice, but you have all the notes now, so you should be good to go. Thanks for tuning in. See you next time.